In the question number 21, the radius of gyration of uniform rod of mass m, length L, about an axis perpendicular to its length and at a distance L by 4 from its one end will be. Okay, so as per the question, this is the rod and this axis passing through the center of mass, and according to the problem, another one is at L by 4. So we can solve this question by using parallel axis theorem. So moment of inertia I, ICM plus md square. Moment of inertia about center of mass for the rod, you know, ml square by 12, and mass into the perpendicular distance between these two axes, that is L by 4. This one. So when you will solve, you will get 7 ml square upon 48. And I know the radius of gyration mk square. If I compare this equation and final moment of inertia of the given situation, so we'll get k is equal to L by 4 root 7 by 3. So this is the radius of gyration. So my option number 4 will be the right choice. Let's move on question number 22. In the question number 22, a hollow sphere of mass m and radius r placed on a horizontal surface, force F acting at a distance x from its topmost point as shown in the figure, the value of x such that hollow sphere start pure rolling without use of friction. So this is a very good question. So we'll see very carefully. I would like to say something. This is a critical value for pure rolling. So first I would like to write, and I will explain all things. Critical. This is given by gamma into r. So you have a question, what is gamma and how you will solve? Gamma you can solve by using moment of inertia of the given body and divide by mr square. Suppose in this case gamma is equal to mr square. I need I, but how you will calculate? You know hollow sphere is there. So I am going to use the moment of inertia of the given body, that is hollow sphere. So we'll write 2 by 3 mr square. So you have the value of gamma 2 by 3. What will be the advantages when you will find the value of gamma? So we'll see. Gamma is 2 by 3. So I can say the x, that is जिसको मैं critical बोल रहा हूँ, इसका value कितना है? 2r by 3 for this type of question. How you will use? 2r by 3 means if force will be at 2r by 3 distance above the center of mass. I would repeat, if force will be at 2r by 3 distance above the center of mass, then hollow sphere will do pure rolling without use of friction. So that is what I am trying to explain. Now, so x is equal to, because total radius is r, minus, because I need to calculate the value of x. So x will be equal to, when you will subtract r, minus 2r by 3. As I said, 2r by 3 is the distance above the center of mass, because center of mass will be here. So you will get r by 3. So the value of x such that hollow sphere start pure rolling without use of friction. So that is r by 3. So I can say my option number 2 will be the right choice. So let's move on question number 23. In the question number 23, a person is spinning with his hand outstretched at the rate of 3 radian per second. So this is omega 1, 3 radian per second. When he brings his hand close to the body, he spins at the rate of 9 radian per second. So now omega 2 9 radian per second. the ratio of initial rotational kinetic energy to final rotational kinetic energy of the person. So first, because there is no external torque, so we can use the law of conservation of angular momentum, I2 omega 2. So if I go for I1 upon I2, will write omega 2 upon omega 1, that will give you 9 upon 3 means 3 upon 1. So K1 upon K2, initial and final. Rotational kinetic energy is given by I1 omega 1 square, 1 by 2, I2 omega 2 square. You have the value of I1 upon I2, 1 by 2, 1 by 2 will cancel out. So 3 upon 1, omega 1 upon omega 2 means 3 by 9 with square. On solving, you will get 1 by 3. So this is the final ratio. So my option number 2 will be the right choice. Let's move on question number 24. In the question number 24, a wheel having moment of inertia 2 upon pi square kg meter square is at rest. So you have to be very careful all data. It is rotated by a 60 watt means power ideal motor for 1 minute means 60 seconds. The angular displacement travels by the wheel on 1 minute. Because we know the power is given by W upon T means rate of doing work. So if I write W, P into T, W means energy. So now energy, because rotated, so we can use the rotational kinetic energy. So I will write half I omega square, that is equal P into T, power is 60 watt. For 1 minute means 60 seconds, so that will give you 3600. And now I am going to put the value moment of inertia according to the problem 2 upon pi square omega square 3600. So 2 will cancel out, and omega square upon pi square I am going to take root on both sides, so will give you omega is equal to 60 pi. This is the angular velocity. And next, you know the power is given by force into velocity in work energy and power. You know. But if I use in the torque, then I can write, because power is given 60 and in this time I am going to use torque instead of general force. So I will write here torque, and I can replace linear velocity by angular velocity. So you know tau is equal to I alpha and omega. This is angular acceleration. And you know when angular velocity is the function of angular displacement, then I can write I omega d omega over d theta. Just like when velocity is the function of position, then acceleration is given by v dv over dx. So that is what? Into omega. So I have omega square d omega on the left hand side 60 divided by the moment of inertia I and d theta. So this is the equation. Now I am going to integrate this one, this one. So limits are according to the problem. I am going to use the limit 0 up to 60 pi, because you know the final value of angular velocity 60 pi, initial was 0, and in the case of displacement 0 up to theta. So these are the limits. Now when you will integrate, you will get omega cube 1 by 3 0 up to 60 pi and 60 upon moment of inertia into theta. And now I am going to use the value, because you know 60 into theta, moment of inertia is 2 upon pi square and 1 by 3. You will write 60 pi, 60 pi, 60 pi. Then you will use the limit. Overall, when you will solve, then you will get theta is 2400 pi radian. So that is what I am trying to calculate. So on behalf of that, we can say my option number 4 will be the right choice. So let's move on question number 25. In the question number 25, a wheel of radius 20 centimeter, moment of inertia 1 kg meter square, can rotate about its center. A string is wrapped over its rim and pulled by a force F tangentially, just like this one. Rim of wheel. If angular acceleration produced is 2 radian per second square, okay, then the value of force is. So you can solve by using simple formula. Tau is equal to I alpha. If I go for torque, I need perpendicular distance and force, and that is equal I alpha. So R is 20 centimeters. So in terms of meter, 0.2 F. Moment of inertia according to the problem 1, and angular acceleration is 2 radian per second square, so you will use that. So when you will solve 2 upon 0.2, you will get 10 Newton. So in this question you need only the basic concept how you will calculate torque. Torque means force into perpendicular distance. Perpendicular distance means this one, because this is the line of action and this is the perpendicular distance, that is radius r. Okay. So I can say my option number 1 will be the right choice. Let's move on. Question number 26.